Now, I'm guessing I don't have to spend a lot of time convincing anybody that our modern networks are extremely complex. In fact, part of the experience of the network engineer and network admin is to be able to log into a network and very quickly try to figure out what's going on when there's a problem. And so let's say that we get that ticket in, and the ticket simply says that they're trying to access a SaaS application, and that SaaS application is having slowness. Now, quick review about SaaS. SaaS means software as a service. This is going to come into play when we talk about ThousandEyes, because ThousandEyes is a software as a service. Simply put, what that means is that our user is trying to access some kind of cloud service. So this application lives in the cloud, which usually means two things. First of all, the application in most cases doesn't need anything installed on the end device. And importantly, we don't need anything installed into our own data centers. This would be the on-premise or private data centers that most of our organizations have deployed to run a lot of different applications. Now, some companies have moved entirely out to the cloud, but software as a service is sort of a little bit of a different animal, because at this point, we don't have to deploy anything, whether it's into the cloud or not. We simply pay some amount of money per month or per day or per hour, whatever it is. We're paying constantly over time for the consumption of this application. So this application might be a Cisco application, sure, but it could also be a Microsoft application, it could be a Google application, it could be a Salesforce application, it could be anything under the sun. And we naturally don't have a whole lot of insight into the infrastructure that these companies are riding on. Maybe they have their own cloud infrastructure. That's probably true for Microsoft and Google and Salesforce, but Cisco doesn't really do that. So they might build on a different cloud infrastructure, such as Amazon Web Services, or maybe even into Microsoft Cloud or something along those lines. But the point of all of this is to say that we don't have a lot of control or insights into their infrastructure. We call this a black box. The black box concept means that this infrastructure just sort of exists almost, I guess we could have this mental picture of a black box and say, okay, I don't know what's inside this thing. It's solid. I can't see through it. I can't see into it. I have no idea what's in there. All I know is that it's performing its job. It's doing its job. I don't need to know the details, and frankly, I don't care about the details. If a network switch goes down inside of Salesforce's infrastructure, then I don't need to worry about that. That is the responsibility of Salesforce, and that is their concern. I am paying them so much money a month so that my users can access their service via the web, and I don't need to worry about anything that's happening inside of their infrastructure. Now, hopefully they have redundancy built into their infrastructure, but again, that's entirely on them. And if they don't have the proper redundancy, then all I know is that my service has gone down and my users are going to do a whole lot of complaining. So let's get back to the issue at hand. We might have this user who's communicating to some sort of software as a service application, and all we know at this point is that there is slowness involved. So in our modern networks, what are we going to do about this? Well, we are going to have to dive into some good old-fashioned troubleshooting techniques. And we have some really good troubleshooting techniques. In fact, we cover a lot of these troubleshooting techniques in various courses here at CBT Nuggets. One of the most popular ones, and the one that I tend to use the most, is going to be divide and conquer. It is simply trying to identify all of the components in our network and split them in half and isolate them and try to figure out, is the issue on one side or the other, and we continue to divide and figure out where the problem is by conquering, I suppose. But ultimately, we're dividing and conquering the problem until we divide it so much that we find what the issue is. The other options that we have are going to be the top-down technique and the bottom-up technique. And depending on our application of these, this might be an OSI model conversation where I start at the top of the OSI model, looking at the application, and drill down until I'm looking at the physical layer, usually meaning the Wi-Fi of the user. And bottom up would flip that around. We'd start at the bottom of the OSI model, layer 1, and work our way up to layer 7. So these are our most common troubleshooting techniques, but there are two big problems with this. First of all, this is reactive. I'm not just logging into the network and using these troubleshooting techniques when nobody's complaining. I'm waiting for somebody to complain. This user needs to tell me there's a problem because I've probably got other things that are better uses of my time than simply looking at everybody's Wi-Fi signal. So it is reactive, and that is a big problem when by the time we really log in and see that we have a ticket, the user's probably been having problems for a while. The other big problem with this is that it's slow. It's slow because we have to first identify the issue and then we can resolve it. And this identification of what the issue actually is, that can take a very long time. Why does it take so long? Well, once again, because our modern networks are extremely complex. They're complex because we have so many different systems all operating at once inside of the environment. And so I drew this wonderful little diagram up here that showed the user connecting to a cloud-based application, and there's just one little arrow in between there. So I could look at this and say, well, we have two systems in place. We have the user and we have the SaaS application. But we all know that there's a whole lot more going on there than just those two components. For example, I already mentioned that this user is probably communicating via Wi-Fi. So we're connecting in through an access point. And this access point is going to go through a switched infrastructure. So we have our local area network that we need to worry about. If I can write that out a little bit cleaner, that might make it a little bit more clear. There we go. So our access point's connected to the LAN. We might have a wireless LAN controller in here, by the way. And so we've got a CAPWAP tunnel we have to worry about. I won't draw that in here just for the sake of reducing the complexity a little bit. So then we're going to go to some kind of layer 3 device. And that layer 3 device is probably a layer 3 switch. It could be a router. We might have to go through a WAN circuit. We might be going back to another layer 3 device in the headquarters, for example. Let's say this is a user at a remote branch site, so they have to connect back to headquarters, and then they're going to get routed through the layer 3 network to an ISP router. And this ISP router then is connected into the ISP network here, and we could draw this as another black box. We could draw it as a cloud, but ultimately, if I draw it like this, I suppose, this could be the ISP's network. It's built on BGP. We have many BGP autonomous systems involved, and so we've got routers in here, lots and lots of routers. And this could be truly dozens of them. I'm just going to draw a few. But ultimately, we are connecting in then to the SaaS application down here. So how many components do we have in this quick network I drew out? Well, we've got the user's PC itself, which might be having problems, so keep that in mind. We have the Wi-Fi signal and the health of the access point. We have the layer 2 network. We have the layer 3 edge. We have the WAN circuit itself. We have more layer 3 routing in here. We have the entirety of the ISP network, which is usually well outside of our control, and for that matter, outside of our visibility. And then we have the SaaS application itself, which falls into that same category. Very difficult for us to know whether that SaaS is having any health issues. So when we talk about identifying the problem, this is where we are going to have to use one of these techniques to try to figure it out as quickly as possible. For example, I might need to find out, hey, is the WAN involved with this? Maybe I think the WAN's having problems. So what do? Well, I split the network like this, and I test the network over here, maybe by running some layer 3 checks to the gateway, and I find out if the problem is still existing. If there's no problem over here, then we know the problem is on this side. That's divide and conquer. And so it doesn't tell me that there's a WAN problem, but it does tell me that the WAN could be the problem. And so now I got to divide over here and test in this way. And we keep doing that again until we figure out what the actual problem is. And so this is why we say this takes so much time. Because by the time I finally identify the issue, I still have to resolve it. I still have to figure out how to fix it. If the Wi-Fi is bad, I have to log into the wireless LAN controller and make some changes, or maybe even walk another access point out there. And so this is, again, time consuming, and it's very, very slow. And so how do we go about resolving this issue? Well, this is where we introduce the concept of network assurance. Network assurance is a little bit of a buzzword these days. And it's, to be clear, it's not only a Cisco concept. The idea here is that we have an analytics engine that's intended to bring in all kinds of inputs. So what are we doing? Well, we're going out to our user PC, ideally, and feeding some information in here. Maybe our access points, our wireless network, our layer 2 network, layer 3 devices. Maybe we get all of this information input into the analytics engine. The analytics engine then is going to run some analytics, and it's going to give us some takeaways. And this process is the assurance piece. This is very beneficial from two perspectives. For one, it helps us to immediately identify any problems, and two, this is proactive. And maybe I should have said proactive first since I said reactive first up here, but either way, we see we're solving the problem that of it being reactive and the fact that it takes a long time for us to know what's going on. So at this point, we might know there's a problem even before the user knows there's a problem. Maybe the users are just starting to log in for the day, and we identify that there's a problem with the wide area network because of all of the information and telemetry is what we call this, that's being fed into the analytics engine. So I get a ping on my phone that says, hey, there is a big old problem here with the wide area network, and users are starting to log into the network. We might want to get this figured out. So I log into whichever one of these devices I need to try to restore the WAN connectivity, and I might even get that fixed before the users start to notice. So that's the big advantage to it being proactive. So here's the downside to this whole model. Notice the arrows I drew. We have arrows coming from the user PC and the access point, the LAN, the layer 3 network, the WAN. All of these components are feeding this analytics engine. Notice what's not feeding the analytics engine. I don't have the ability to export information from all of these ISP routers. I don't know what's happening from a BGP perspective, and I certainly don't know what's happening inside of the SaaS application. So what if the problem actually exists over here? What if the SaaS application's having some slowness? Or what if there's a massive BGP convergence event on the internet and it's causing the problems? Well, my network assurance engine here, this analytics engine, is not going to have any insights into that. And the reason for that is simply because I'm not feeding it any information. I can't send it any log information. I can't send it any NetFlow information, syslog, any of these components that normally I'm feeding in. They're not coming from these other components. It's not a complete view. It's not a global view. And so furthermore, we might actually find that, yeah, I've got control over my own network. And this is great if I have DNA Center involved. And these days we call it Catalyst Center. But either way, that's great from a LAN campus type of perspective, but the data center might be built on Cisco ACI. And we might have our WAN environment wrapped up with software-defined WAN, which does feed into DNA and Catalyst Center, but ultimately we might have many different components on the network. What we need is ideally a global view. And this global view needs to, yes, take my own network into account and all of the pieces of my network, whether that's the campus or the data center or all of the above, but I also need to take information from the internet service providers. I need to take information from the popular SaaS providers and help me to see what's happening end to end so that I know everything about anything that I want to know about. And so that is what's going to lead us to ThousandEyes. ThousandEyes is meant to give us this global view. It's intending for us to be able to take data and information not only from our network, but also from the global ISPs and software as a service providers. And the cool thing about it is Cisco has already deployed all of the agents into the public space that we need in order to run these tests. All that's left for us is to get our network on board. But either way, let's go ahead and call this conversation good. Again, like I said at the very start of this video, I probably don't need to convince anyone that our networks are complex and difficult to find resolutions to tickets. But we at least want to take this away from the conversation. We should recognize that our common Everyday methods for troubleshooting not only have to wait for a ticket to be submitted, that's the reactive part, but also it takes me a long time potentially to identify the issue, especially for something like slowness. I know I always dreaded getting the ticket that reports network slowness. That is very painful. And so we want to get away from this. We want to be proactive. We want to immediately identify the issue and ideally either fix it before the users notice, or at a minimum, by the time the users notice and open up a ticket, we can come back to them and say we are working on it and we expect to have that resolved soon.